In some cases, an attacker is able to manipulate the website into loading unintended code and take control over JavaScript execution in other users' browsers. Cross-site scripting is a vulnerability impacting a user's browser. It's been around for 30 years and seems to affect every website. Regardless of its 30 years of existence, it is still considered one of the most exploited web vulnerabilities in the world, ranking it at number 3 most exploited. Let's start with the definition. Cross-site scripting is the ability to inject and execute malicious scripts in a victim's browser within the security context of a vulnerable website. That's a lot to unpack, so we'll break it down. Let's explore the definition, starting with the ability to inject. The basics. You type a URL into your browser. The browser sends an HTTP request. The request is passed on to a target server and is processed. The server then produces an HTTP response which is passed back to the browser. The response is processed and the visual is produced. The ability to inject refers to the user's level of control of the response. There are many types of responses: image types, videos, APIs. However, in this video, we will look into an HTML response. An HTML response may comprise of 3 components: HTML, CSS, and JavaScript. HTML is a textual language that represents a web page. Over the years, it has become more powerful with the addition of various features, but at its core, it is simply a skeleton of a web page. Before us, we see 2 pages that are, in fact, the same page. One is made using only HTML, and the other also has CSS. If HTML is a skeleton, CSS would be the haircut, clothing, and makeup. It adds beautiful visuals, and its newer features even allow you to use animations. Finally, we have JavaScript, and JavaScript is weird. When the browser processes our HTML, it creates something called a document, which is also referred to as the DOM. HTML is used to construct the original DOM. CSS makes the DOM pretty, and JavaScript allows a programmatic way to manipulate the DOM. With JavaScript, you can add or remove elements from the DOM. You can do that when a button is clicked. You can notify the user that something went wrong. With JavaScript, you have full control of the DOM, and therefore, full control of the website. Under normal conditions, a website developer is the one writing the HTML, CSS, and JavaScript that a user browser renders and executes. But in some cases, an attacker is able to manipulate the website into loading unintended code and take control over JavaScript execution in other users' browsers. For the purpose of the demonstration, we created a fake bank called SecureBank. We have a private section for users in which they receive a greeting message and are able to view their balance along with previous transfers. They are also able to transfer money to other users and add a reason for documentation purposes. John is a user of this application, and as a talented hacker that he is, he has figured out that by performing a money transfer transaction, he can inject malicious code into the transfer reason text field. John notices the location within the HTML in which the server inputs the reason for transfer. He experiments and manages to trick the browser. You see, this is the text John wrote. This text is sent back to another user, and the browser sees the data message being only the word money. Then, the next word, autofocus, is applied as an attribute of the button tag. The next combination is more elaborate. The onFocus and the text applied to it are a way to pass code into the JavaScript engine. This method is called event handling and is a normal and legitimate way to make a website more dynamic. John, as a user of the application and not a developer, should not be allowed to inject code into the JavaScript engine. Armed with this knowledge, John now builds the real cross-site scripting attack. He creates an invisible window and performs a money transaction in the background. The attack is compressed and the malicious payload is finally ready. John decides to attack David. a successful businessman. He logs in and performs a money transaction of $10 to David's account. In the transfer reason field, he types in the malicious payload, which includes the word donation. He also does this such that David, when he receives the transaction, would not suspect of any foul play. The transaction is successful. John only has to wait for David to log in. David checks his bank account every day. He receives money from deals he's made and likes to stay on top of things. Today, something grabs his attention. Someone seems to have donated $10 to his account. David is suspicious, but thinks nothing more of it. Meanwhile, as the donation is loading into David's browser, it also executes the malicious JavaScript code that John wrote. John now controls David's browser and performs a money transaction on behalf of David. David has now paid $30,000 to John, while being completely oblivious to this attack. David logs out and a day goes by. The following day, David logs into his account and discovers the loss of $30,000. He panics and sees the transaction was done by him the day before, and the message that says, "A gift for my friend." Looking back at our definition, XSS is the ability to inject and execute malicious JavaScript code in someone else's browser, like David in our example. As the code is executing in their browser, an attacker can take full control of the DOM, therefore fully controlling the vulnerable website, or in other words, executing code within the security context of a vulnerable website. Let's discuss ways to mitigate cross-site scripting. First and foremost, we have CSP, which stands for Content Security Policy. In essence, the web server tells the browser which JavaScript sources are legitimate to load. When configured correctly, you can forbid the form of JavaScript used in this video from ever executing, regardless of its origin. This method could clash with existing code and requires delicate implementation work. The second method would be sanitizing and validating input as it arrives in the server. The developer looks for dangerous characters like single quotation and double quotation marks, along with other known XSS injection techniques. Because this is a difficult task, many choose server-side libraries that handle this. Due to its unreliability though, this should only be an additional method in your XSS mitigation strategy, and not the only one. The third method refers to escaping output. This includes using XSS-safe HTML attributes, XSS-safe client-side frameworks, and templating engine features that prevent JavaScript code execution where the developer handles potentially unsafe data. You should never embed user input into raw JavaScript code. It is extremely difficult to ensure this code remains safe, and it is seen as a security violation in every case. Applying these mitigations to your web application can be complicated. There are many nuances to using each, and in some cases, they may even clash with one another. At CByte, we will help you identify, mitigate, and remedy vulnerabilities such as cross-site scripting and others with the help of our experts. Find us at cbyte.cz for your trusted security journey.